All right, if you're in the Java world, you've definitely heard people talk about the magic of Spring Boot, right? It's like it just knows what you're trying to build. But here's the thing, it's not magic. Not at all. It's actually a really clever system of automation. So in this explainer, we're going to pull back the curtain and show you exactly how it all works under the hood so you can really start building things way, way faster.
Craig Walls put it perfectly in his book, Spring Boot in Action. He uses this amazing analogy. Think about it. Traditional Java development can feel like you're fighting with this giant, heavy manual door. You're wrestling with configurations, managing all these dependencies, writing tons of boilerplate code. But Spring Boot, it's that automatic door. It just sees you coming and whoosh, it opens right up.
Okay, so how does that automatic door actually work? What are the sensors? What's the motor? How does Spring Boot just know what we want and make everything so smooth? That's the real question, and we're about to dive in and break it all down.
So Spring Boot's whole automation thing really stands on a few key pillars. We're going to look at starters, which are like your toolkits, then auto configuration, how it handles different environments, and even what it gives you for when your app is live and production. And then we'll see how it all comes together for building microservices. Let's get started with the first piece.
All right, first up, let's talk about the first pillar of Spring Boot's automation, starter dependencies. The easiest way to think about these? They're basically pre-packaged toolkits for whatever job you're trying to do. Starters are here to solve a problem that every Java developer has felt, dependency hell. You know, that nightmare of hunting down dozens of different libraries, making sure they're all compatible just to build a simple web app. With starters, you forget all that. You just include one single starter and bam, it's a one-stop shop that pulls in everything you could possibly need for that specific task. And this slide just shows it perfectly. Look at the left, that's the old way, a huge, messy list of individual dependencies you had to manage yourself. Now look at the right, that's the Spring Boot way. You just add one thing, Spring Boot Starter Web. That is it, one line, and it pulls in everything you see on the left, and more, including a whole embedded web server. Okay, so you've got your toolkit, right? The starters pulled in all the right libraries. But now you have to configure all of them, which sounds like a ton of work. Or does it? Well, not so fast. This is where the second pillar comes in, and this is where that magic really happens. We're talking about auto configuration. I mean, the official docs say it best. Spring Boot basically looks at the jar files on your class path, the ones you got from your starters, and it makes an educated guess. It's like it says, aha, you've got Tomcat and Spring MVC libraries here. I bet you're trying to build a web application. And then it just goes ahead and configures it for you. So here's how it works, step by step. 1. You add that Spring Boot Starter Web to your project. 2. When your app starts up, Spring Boot scans everything available, your class path, and it sees those Tomcat and Spring MVC libraries. And 3, based on just seeing those files, it automatically sets up all the necessary pieces, or beans as they're called in Spring, like the main web controller, and it even fires up that embedded Tomcat server. And just like that, you have a running web server without writing a single line of config code. It's pretty amazing.
Now, this is super important. People say Spring Boot is opinionated. And it is. That just means it makes some smart, sensible decisions for you by default. But, and this is a big but, it is not a dictatorship. If you don't like a default setting, you just define your own configuration for it. As soon as you do, Spring Boot backs off and says, okay, you got this. You are always in the driver's seat.
All right, so your app is up and running. Awesome. But now you have to think about running it in different places, right? Like on your local machine for development, on a server for testing, and then in production. Each one needs different settings, like which database to connect to or what API keys to use. That's where a third pillar comes in and really shines. The big idea here is what's called externalized configuration. It's all about separating your code from the settings it uses. So you can build your application once into a single file, and then you can run that exact same file in different environments just by giving it a different set of configurations. This makes everything so much more portable and way easier to manage. And Spring Boot is super flexible about where it gets these settings from. It can read from simple properties files or more organized YAML files. It can pull them from your operating system's environment variables or even from arguments you pass in on the command line. And there's a really clear hierarchy. So a command line argument will always beat an environment variable, which will beat a setting from your properties file. This system, especially when you use profile-specific files like application dev.properties for development, is what makes juggling different environments so powerful. So your app is built, it's configured, and now it's deployed out in the wild. But what happens next? How do you know if it's actually healthy? How do you peek inside and manage it while it's running? This brings us to the fourth pillar, which is all about giving you production-ready features from the get-go.
And that's the job of something called the Spring Boot Actuator. It's, you guessed it, another starter that you can just add to your project. And the second you do, it gives your app a whole set of web endpoints for monitoring and management. It's seriously like getting a built-in dashboard and control panel for your application for free.
I mean, just look at what you get right out of the box. There's a health endpoint, which is absolutely crucial for any automated system to check if your app is still alive. There's metrics, which gives you tons of insight into performance, like memory usage. And my personal favorite, loggers. This one is amazing. You can actually change the logging levels of your application while it's running, without a restart. That is an absolute lifesaver when you're trying to debug a tricky issue in production.
You know, one of the best things about this whole system is the flexibility it gives you. By default, Spring Boot uses an embedded Tomcat server, but what if you prefer something else, like Jetty or Undertow? Swapping them out is incredibly easy, and that choice can actually matter. As you can see from this simple benchmark, for this specific test, Undertow and Jetty were actually a bit faster than Tomcat. The point is, Spring Boot makes it trivial to experiment and pick the absolute best tool for your specific job.
Okay, let's zoom out for a second. We've talked about the 4 pillars, right? Starters, auto configuration, externalized config, and the actuator. So what happens when you put them all together? What does all this automation actually enable? Well, it turns out it provides the perfect blueprint for building modern cloud-native applications, specifically with a microservices architecture.
Yeah, that's really the key takeaway. Each of these features is like the perfect ingredient for building microservices. You can spin up new, small, independent services incredibly fast. That's thanks to starters and auto configuration. You can manage their settings across all your different environments using externalized config, and you can keep an eye on all of them with the actuator. It all just fits together.
And this diagram really shows you that big picture. This is a pretty standard microservices setup. You've got an API gateway at the front, routing requests to all these different independent services, a payment service, a pricing service, an inventory service. Each one has its own database. There's a central config server managing all those externalized settings we talked about, and a service discovery tool so they can all find each other. The amazing part is, Spring Boot, along with the bigger Spring Cloud ecosystem, has tools to build every single piece you see in this diagram.
So let's bring it all the way back to where we started. It's clear now, right? Spring Boot isn't magic. It's just a really, really well-designed system of smart defaults and powerful automation. It makes intelligent, opinionated choices to get you started quickly, but it always lets you take back control when you need to. And the whole goal is simple. Get rid of all the boring, repetitive boilerplate code so you can focus your brainpower on what actually matters, building your app.
So, by taking care of all that tedious, repetitive work, Spring Boot gives you back the one thing you can't get more of, your time and your focus. It's that automatic door opening up for you so you can just walk right through. So the only real question left is, what are you going to build with all that newfound freedom?